Good afternoon, my chemistry minions. Lecture number 2 for nuclear. Today we are going to delve into the types of decay and be able to write balanced equations for what the kinds of decay we learned from last video. Alpha decay, beta decay, gamma emission, and positron emission. Okay. The radioactive isotopes are unstable and will decay into other elements, but there are different kinds of decay. Okay, and we learned about the different particles. Last notes. So, radioactive decay, of course, we're following along again, just like last notes, because the stuff is pre-written in. Unstable neutron to proton ratio. Alpha decay. Alpha decay, this is a transmutation whereby an unstable nucleus emits specifically alpha particles. Alpha particles are produced in the reaction, and the nucleus becomes smaller with less positive charge. Okay. Alpha emission is characteristic of a heavy nucleon, especially if it's greater than 83. So let's take a look at what the picture says. It'll show us what this alpha decay looks like. Okay. An alpha decay, I could take this Pu, plutonium, right? 94, 240, and that's going to go to uranium, 92, 236, plus this alpha particle, which is He24. So you see how there's two arrows in the picture? It's because the plutonium is going to become these two things. This is generally how we write it, okay? In what looks like a chemical reaction. Okay. Alpha decay can be summarized as follows. The atomic number is going to decrease by 2 because the alpha particle has that 2 protons. That's why we write helium there. Okay, the number of protons decreases by 2. Oh, and there's some review of atomic concepts, right? The atomic number is the number of protons. That's why they both decrease by 2. Okay, the total mass is going to decrease by 4. That's because the mass on the helium is 4. The number of neutrons will decrease by 2. Remember, the mass equals the protons plus the neutrons. If I have a total mass of 4 and I have 2 protons, I must have 2 neutrons. Okay. When we do these, though, what's nice about these is it's really just a simple math game. Okay. We're going to complete the example problems with alpha decay. Remember, the charge and the mass must be conserved. So if I go from francium, 87, to something with the helium with the 2, well, 2 plus what is 87? Oh, 85 plus 2 is 87. There we go. And 4 plus what is 220? We just walk it right backwards, right? Well, 4 plus 216 is 220. So now I've conserved my mass, and I've conserved my charge as far as the protons go. But what I don't know is what symbol. So I'm just going to go to the periodic table and look up 85. You can use table S if you'd like. I tend to use the periodic table. 85 is antnium, I believe, AT. Might be antimony. It's one of them. But all you need to know is it's AT. And we're good. All right. Now, this last one, it doesn't quite show us, but it did say I was going to alpha decay. So I already know that this is now He2 and 4. I know that because it said it was going to alpha decay. And if you can't remember that that's alpha, we look at table O and figure out that alpha is this helium with the 2 and the 4. Now it's the same as before. 2 plus what is 86? 2 plus 84. And then 4 plus what is 222? Looks like 218. And now I'm going to use my periodic table to look up what 84 is. PO. It's that simple. It's really not that hard. 2 plus 84 equals 86. I can do that without a calculator. All right, now we got beta decay. Okay, so again, I'm going to have this big cesium, CS with a 55 and a 137, become Ba 56, 137 plus, oh, so 56 plus what is 55? Oh, 56 plus a negative 1. Okay, I remember beta is the E, and 137 plus what is 137? 0. So there I can figure out what my beta particle is emitted, and that's what my beta particle is going to look like, or that E with a negative. It's like an electron. Okay, no mass, charge is 0. Okay, there we go. Decay can be summarized as follows. The atomic number decreases by 1, because it's not an electron. The protons are increased by 1. I'm sorry, they're both increased. The mass stays the same. The neutrons decreased by 1. In order to keep the mass to stay the same and I add a proton, the neutrons must change. So let's fill this in following beta decay. Well, since it's beta decay, can I do this right off the bat and put both of them as beta decay? Right? And now it's just a simple math. -1 plus what equals 15? -1 plus 16. And that makes sense because it just said the protons will increase by 1. Well, if I was 15 and I increased by 1, wouldn't I have 16? Absolutely would, Mr. Milks. 0 plus what is 32? 32. Look at my periodic table. Which element is got 16 protons? Sulfur. Okay. Here's carbon 14. -1 plus 7 equals 6. 0 plus 14 equals 14. 7 protons is nitrogen. Starting to get the hang of this yet? -1 plus 83 equals 82. 0 plus 214 equals 214. Let me look up 83 because I definitely don't know these ones off the top of my head. Bi. It's that simple. Piece of cake. Piece of cake. I don't like these decay things, and I don't like to memorize them, but guess what? The positrons, these beta decays, I don't have to memorize them. They're right in the periodic table for me. All right, let's do positron emission. I'm going to do this again on the board. Na1122, 11 and 22 becomes this E with a positive 1 and a 0 plus Ne with a 10 and a 22. And notice it all works out. 10 plus 1 is 11. 22 plus 0 is 22. We're good. And I look up 10 on the periodic table, I get Ne. Okay. So now we have some more to do. Let's sum it up real quick, though. The atomic number now is going to be decreased by 1. The number of protons, again, are decreased by 1 because the atomic number and the number of protons are the exact same thing. The mass is going to stay constant. So the neutrons increases by 1. It's got to go up in neutrons if I'm losing a proton and my mass is the same. So I'm switching those out. So let's do the math real quick. Well, before we do that, let's fill in all the positrons because it's all going to be positron decay. So let's fill in our positrons. And now it'll be easy to do the math. 1 plus what is 19? That'd be 1 plus 18. 0 plus 37 is 37. Check out number 18 on my periodic table. I have Ar, argon, I believe. Keeping moving right along. 1 plus what is 37? I got 36. 0 plus 81 is 81. Looking up 36. Kr. 1 plus 9 is 10. 0 plus 19 is 19. Let me look up my 9F. Piece of cake, Mr. Milks. I'm really getting the hang of this, and I'm slightly a little bit bored already. We got one more to do. Gamma radiation. No mass, no charge, just energy. Makes them the most destructive. Notice, there's just a wave. Just energy. Okay? So it just gives off energy and energy and energy, and it's the most penetrating, harmful kind of energy there is. Now that we are done with this video, we can write alpha, beta, and positron decay equations. Okay, we can practice pages 4 through 8 now. And now after we did prep number 1, we can now do quiz number 1. And yes, Mr. Milks, we are going to do all of our quizzes before they close this time. Hoorah! See you guys tomorrow in class.